Welcome to the Collapsed Spine Architecture module. By the end of this module, you should be able to describe a collapsed spine architecture. In collapsed spine fabrics, the overlay functions are collapsed to the spine. There are no leaf devices in a collapsed fabric. The spine devices provide conductivity between endpoints through back-to-back connections or by using route reflectors. In the absence of leaf devices, the top-of-rack switches connect directly to the spine. The top-of-rack switches can be multi-homed to the spine using aggregate interfaces configured locally, with the spine endpoint configured as Ethernet Segment Identifier Link Aggregation Group or ESI-LAG interfaces. A collapsed spine provides the ability to build a fabric using switches that do not support Ethernet VPN Virtual Extensible LAN or EVPN-VXLAN. Later, you will see how the collapsed spine EVPN-VXLAN fabric network is constructed layer by layer. For the current list of devices that support collapsed spine fabrics, you can refer to the Juniper Pathfinder website as mentioned in the reference links document in the resources section. Here you can see that the underlay comprises both Layer 2 and Layer 3 components. In this design, each access node is connected to all spine nodes using Layer 2 technologies. The connection made from the leaf's perspective is a standards-based LAG interface. Each spine node is connected to all other spine nodes, if using over 2 spine nodes, using Layer 3. Some methods must enable the exchange of loopback information between the spine nodes. The loopback interfaces are used by the BGP overlay network to establish EVPN peering sessions. This example uses external BGP or eBGP. However, internal BGP or IBGP, OSPF, ISIS, or some other method can provide this functionality. This design eliminates the requirement for spanning tree while providing a highly scalable architecture. In the overlay of the EVPN-VXLAN spine-only design, IBGP is used to carry the EVPN-controlled data by configuring family EVPN signaling. The autonomous system or AS number used for the IBGP session differs from the AS numbers used in the underlay if eBGP is used as the underlay protocol. EVPN monitors for new entries in the local switch and bridge tables. Any new media access controls or MACs are sent to the other spine nodes using BGP update messages, and based on matching route targets, the MAC is added to their local switch and bridge tables. EVPN provides support for both ESI and ESI lags in an EVPN network. Ethernet segment identifiers enable multi-home devices to connect to 2 or more devices that are part of the EVPN network and determine that traffic on either link is from the same Layer 2 device. ESI lag provides a mechanism for an external device to connect to 2 or more nodes in an EVPN network using a standards-based lag. Both ESI and ESI lag require additional configuration to ensure that the EVPN nodes identify the individual links as being part of a common Ethernet segment. VXLAN tunnels are also part of the overlay. Additional settings must be configured to integrate VXLAN with EVPN. The last part of configuring the overlay is to configure the VXLAN data plane to use EVPN as its control plane. EVPN and VXLAN are not a single technology, but 2 technologies that can work together. EVPN does not encapsulate the Layer 2 traffic across a Layer 3 network. For this, it requires a data plane tunneling protocol. VXLAN is one choice. Another option is MPLS, which is commonly used in service provider networks. VXLAN is considered the best choice for enterprises and data centers. VXLAN is not limited to EVPN for its control plane. Other technologies, such as multicast or a software-defined networking or SDN controller like Contrail, can provide the same functionality. Multicast was defined in the VXLAN RFC 7348 Virtual Extensible Local Area Network or VXLAN as a control plane mechanism. EVPN offers a more reliable way than multicast to learn MACs. Using an SDN controller like Contrail minimizes the need for manual configuration to build the EVPN-VXLAN network. This solution is more expensive and requires major changes to an existing network to be implemented. VXLAN with an EVPN control plane offers the best combination of technologies for moving an existing Layer 2 network to the newer IP-based architecture. Welcome to the Underlay Network module. By the end of this module, you should be